Salt batteries are here. America's electric truck future may be standing on a battery formula that is already beginning to crack. For years, the promise sounded simple. Take the pickup truck, replace the engine with electric motors, fill the floor with a massive lithium battery, and Detroit would carry its truck empire into the electric age. The Ford F-150, Lightning Chevrolet, Silverado EV, and Ram's electric future were all built around that belief. But there is a problem hiding under the floor. Lithium truck batteries are expensive. They are heavy. They depend on difficult supply chains. They lose confidence in winter. And when a truck has to tow haul and survive American highways, the battery pack must become enormous just to protect the promise. Now, sodium-ion batteries are entering the fight. Not as a perfect replacement for every long-range truck, not as a miracle chemistry, but as something more dangerous, a cheaper, more abundant battery path that could attack the lower and middle layers of the EV market. If that happens, lithium trucks may face a brutal 2027 shock, not because salt batteries beat them at everything, but because they may expose how expensive the lithium truck formula really is. The battery formula Detroit believed in. To understand why sodium-ion matters, you first have to understand how lithium became the center of America's electric truck strategy. Lithium-ion was not chosen by accident. It offered high energy density, strong power delivery, and enough maturity to move EVs from experiment to mass production. Tesla proved that lithium could make electric cars fast, desirable, and realistic. Once that happened, the rest of the industry had to respond. But Detroit faced a harder problem than Tesla. Tesla built electric sedans and crossovers first. Detroit had to protect the most profitable vehicle class in America, the pickup truck. That changed everything. A truck is not judged like a small commuter car. It has to tow. It has to haul. It has to survive winter mornings in Michigan construction sites, in Texas, mountain roads in Colorado, and long highway stretches where range anxiety becomes a business problem, not just an inconvenience. So the logic became simple. If an electric truck must behave like a real American truck, it needs a massive battery. That is how lithium became the foundation of the electric truck formula. Bigger pack, longer claimed range, more torque, more capability, more reassurance for skeptical buyers. But this formula created a hidden cost. Every extra kilowatt hour adds weight. Every extra module adds expense. Every larger pack demands more cooling, more crash protection, more warranty exposure, and more pressure on the supply chain. Detroit was not wrong to use lithium. It was the best available path. The danger is that the industry began treating it as the only path. And once a technology becomes the only path, every weakness inside it becomes a strategic vulnerability. The physics problem hidden under the floor. The problem with lithium trucks is not that the technology does not work. The problem is that trucks punish batteries harder than almost any other consumer vehicle. A sedan can be optimized around efficiency. A crossover can balance weight, range, and comfort. But a pickup truck is a different machine. It has a large body, a heavy frame, bigger tires, more aerodynamic drag, and a customer base that expects it to do real work. That means the battery is not just powering transportation. It is powering identity. It has to protect towing confidence. It has to protect payload confidence. It has to protect winter confidence. It has to protect the belief that an electric truck is still a truck, not a compromised appliance with a bed. This is where lithium becomes expensive fast. When an automaker adds more range, it usually adds more battery. More battery means more cells. More cells mean more raw materials, more cooling, more structure, more weight, and more cost. But in a truck, that weight creates a loop. A heavier vehicle needs more energy to move. More energy requires more battery. More battery adds more weight again. It is a mechanical debt spiral. And towing makes it worse. When a truck pulls a trailer across Texas or climbs through Colorado, aerodynamic drag and rolling resistance rise sharply. The battery is no longer just moving the truck. It is moving the truck, the trailer, the load, the wind, the grade, and the driver's expectation that nothing should feel weaker than a gasoline pickup. That expectation is extremely expensive to electrify. Then winter arrives. Cold weather does not politely reduce range on a spreadsheet. It hits chemistry, charging speed, cabin heating, and driver confidence at the same time. A truck owner in Michigan does not care that the vehicle performed well in ideal conditions. He wants to know what happens when the battery is cold. The road is icy, and the trailer still has to move. So the lithium truck formula becomes heavier, more complex, and more expensive just to defend itself. That is why sodium-ion matters. It does not have to beat the largest lithium truck pack in every category. It only has to make the market ask whether every truck really needs that expensive lithium fortress under the floor. The battery that does not need to win every fight. Sodium-ion is dangerous because it changes the question. For years, the EV battery debate was dominated by one measurement: how much energy can you pack into the smallest and lightest space? Under that rule, lithium had the advantage. It is lighter. It stores energy well. It became the obvious answer for long-range electric vehicles. But the EV market is not made of only long-range premium vehicles. It is made of commuters, work fleets, local contractors, city departments, delivery routes, budget buyers, and people who do not want the most advanced battery in the world. They want the most useful battery they can afford. That is where sodium-ion enters. Sodium is more abundant than lithium. That does not make sodium-ion free or simple. Battery production is still difficult. Cell quality still matters. Manufacturing scale still matters. But sodium-ion attacks one of the most sensitive weaknesses in the lithium system: material pressure. If a battery chemistry can reduce dependence on lithium while still delivering enough range for daily driving, enough durability for fleet use, and enough cold weather confidence for northern states, then it becomes strategically disruptive. Not because it is perfect, because it is sufficient. And sufficient can be deadly in a market under cost pressure. A sodium-ion battery does not need to power the most extreme electric truck on the road. It does not need to tow across Colorado at maximum weight. It does not need to outrange every luxury EV. It only needs to serve the parts of the market where lithium is overqualified and overpriced. Local work trucks, short route delivery vehicles, municipal fleets, affordable EVs, hybrid buffer batteries, range extended platforms, cold weather commuter vehicles. These are not glamorous categories, but they are exactly where cost discipline matters most. And this is the trap for lithium trucks. The more lithium batteries are used to defend range towing and capability, the more expensive the truck becomes. But if sodium-ion proves that many buyers do not need that much battery for their actual use, then the lithium formula starts looking bloated. A heavy lithium truck may still be impressive, but impressive is not the same as affordable. This is why 2027 matters. If sodium-ion scales into real automotive production, the market may begin separating vehicles into two groups: those that truly need lithium and those that were only using lithium because there was no mature alternative. That separation could be brutal, because once buyers realize they do not need the most expensive chemistry for ordinary driving, the pricing power of lithium-based EVs weakens. And when pricing power weakens, the entire business model starts shaking, where lithium trucks start looking vulnerable. To see the sodium-ion threat, clearly compare it against the trucks America already understands. Start with the Ford F-150 Lightning. The Lightning carries one of the heaviest burdens in the EV market, because it is not just another electric vehicle. It is the electric version of America's best-known work truck. That means buyers do not judge it only by acceleration or touchscreen size. They judge it by trust. Can it tow? Can it survive winter? Can it work all week? Can it justify its price when gasoline F-150s already do the job? That is where lithium becomes both the solution and the problem. A big lithium pack gives the Lightning power and range, but it also adds cost, weight, and pressure. The more capability Ford needs to promise, the more battery the truck needs to carry. And the more battery it carries, the harder it becomes to make the truck feel affordable to the buyer who actually made the F-150 famous. Now look at the Chevrolet Silverado EV. GM's approach leans into scale size and long-range ambition. That makes sense for American truck psychology. Range calms fear. Big numbers create confidence. But large battery packs also make the vehicle more exposed to lithium pricing pack complexity and production cost. If sodium-ion begins creating cheaper EV options underneath the Silverado EV, the pressure does not come from beating it at maximum range. It comes from making some buyers question whether they ever needed that much expensive battery in the first place. Then there is Ram's electric future. Ram has to defend a customer base that expects comfort, strength, towing identity, and long-distance usefulness. That is a hard job for any electric truck. It becomes even harder when the battery chemistry underneath the vehicle is tied to a high-cost material system. This is the common weakness across all three brands. Ford, GM, and Ram are trying to electrify vehicles that were never designed around energy restraint. American trucks were built around power, size, confidence, and excess. Lithium can support that formula, but it makes the electric version expensive. Sodium-ion attacks the opposite side of the market. It says not every buyer needs maximum range. Not every work truck needs extreme towing. Not every fleet needs a battery fortress. Some buyers need a cheaper electric tool that works predictably inside a defined mission. That is where the shock begins. Because once the market accepts cheaper mission-specific EVs, lithium trucks must defend their price with real necessity, not just tradition. And tradition is a dangerous thing to rely on when the spreadsheet turns against you. Supply chains, tariffs, labor, and the 2027 battery question. The sodium-ion threat does not stop at the battery pack. It moves into the entire industrial system behind the truck. For years, America has been trying to rebuild EV independence around lithium. That means mines, refining plants, cathode materials, battery factories, recycling networks, tax credits, and supply agreements. The goal is clear. If the battery is the new engine, America cannot afford to depend on someone else for the engine of the electric age. But sodium-ion complicates that strategy. It does not erase lithium. It does not make every lithium investment useless. High-performance EVs, long-range trucks, and heavy-duty applications may still need lithium's energy density for years. But sodium-ion creates a second path. And once a second path exists, the market starts asking a dangerous question: how much of the EV future truly needs lithium? That question can shake investors. Lithium miners, battery startups, cell manufacturers, automakers, and suppliers have all built plans around long-term lithium demand. If sodium-ion takes even a meaningful share of commuter EVs, fleet vehicles, delivery platforms, and lower-cost truck applications, then part of that demand curve has to be recalculated. Detroit feels the pressure even more directly. Ford, GM, and Stellantis must electrify without destroying their truck economics. They need to protect margins, keep factories running, satisfy union labor, meet regulations, and convince buyers that electric trucks are worth the price. That is already difficult with lithium packs. If a cheaper chemistry begins setting a lower cost benchmark, the pressure grows. This is where tariffs become complicated. Tariffs can slow down foreign vehicles. They can protect domestic showrooms. They can buy time for American factories. But tariffs cannot make an expensive battery cheap. They cannot turn a heavy lithium truck into an affordable work vehicle. They cannot invent a mature sodium-ion supply chain overnight. A tariff is a wall. A chemistry shift is a tunnel under the wall. And labor sits directly in the middle of that tunnel. American factory workers are not only competing with cheaper production overseas, they are competing with different manufacturing economics. If sodium-ion lowers material pressure and simplifies the cost structure for certain vehicle classes, then American plants must answer a harder question. Can they build the right chemistry at the right price before the market moves? That is the real 2027 shock. Not a single truck losing a drag race. Not one sodium-ion vehicle replacing every lithium pickup. The shock is a repricing of assumptions. The assumption that lithium will own the entire EV transition. The assumption that bigger packs are the only way to create confidence. The assumption that policy can protect Detroit faster than chemistry can change the market. If sodium-ion scales, America will not only be defending trucks, it will be defending the economics behind them. The lithium truck formula is no longer untouchable. Sodium-ion has not ended lithium. It has not destroyed the Ford F-150 Lightning. It has not erased the Chevrolet Silverado EV. It has not made Ram's electric truck strategy meaningless. Lithium will still matter wherever range, power density, and heavy-duty performance demand the strongest battery chemistry available. But the threat was never instant replacement. The threat is exposure. Sodium ion exposes the weakness inside the lithium truck formula. The weight, the cost, the supply chain pressure, and the assumption that every electric vehicle must carry the most expensive chemistry just to be taken seriously. If salt-based batteries become good enough for daily driving local fleets, winter commuters, and lower-cost work vehicles, then lithium trucks will face a harder question than range. They will have to justify their price, and that is where industrial power begins to move. Because the future of electric trucks may not be decided only by horsepower towing numbers or massive battery packs. It may be decided by which chemistry can scale, survive winter lower costs, and reach buyers who cannot afford a six-figure experiment. Lithium built the first serious EV revolution, but sodium ion may reveal its limits. And if Detroit waits until that limit becomes obvious, the 2027 shock will not be that salt can power a vehicle. The shock will be that America saw the crack coming and still kept building on the same expensive floor.